Okay, let's keep diving into what a derivative is going to tell us in relationship to a graph. All right? Okay, so if I have something like this, here's some things that our derivative is going to tell us. Anytime you have a horizontal tangent, so my slope here is 0, because it's a horizontal tangent, that automatically tells us we're either going to be a maximum or a minimum. That's what we talked about last time, right? Also, if your graph here at this point has a positive slope, what is happening to your graph there if I have a positive slope? Yeah, that means that I have an increasing graph. So if the slope of my tangent line, we're talking about derivatives here, right? And this derivative is the same thing as the slope of a tangent line. So if the slope of my tangent line at a specific point is positive, that means my graph is increasing. If I have a slope that is negative, what's that tell me? Exactly, decreasing graph. Right on. Okay, so increasing, decreasing. Now here's the deal. We said that this could be either positive, this could either be a maximum or minimum. So yeah, let's take a look at that. If I have a horizontal tangent, right? Again, this is going to be a maximum or a minimum. In this instance, it's going to be a minimum. Max or min. In this instance, it's a minimum. In this top instance, it's a maximum. But the same kind of deal. Right here, if I have, we'll stick with the same colors, a negative slope, guess what? My graph is decreasing. If you have a positive slope to your tangent, that's increasing. Right? Okay, that's the deal. So regardless of if it's positive or negative, that tells you if your graph is increasing, decreasing. It doesn't matter if it's going up like this or down like this. You just know if my graph is increasing, then chooses to decrease, then I've got a maximum or a minimum in there. Well, maximum, right? Increasing, something's happening, and then it decreases. So when I have that critical value here, I know that's a max. So in order to determine if it's a maximum or minimum, I look at what my graph is doing around that value. So if it's decreasing to increasing, then I know I have a minimum that goes there. Okay, check this out. We want to look here at example 1. We're going to sketch a graph to satisfy these conditions. Sketch a graph to satisfy, oh my goodness, satisfy these conditions. It is a continuous graph. That's important to know. From negative to positive infinity. So it's continuous everywhere, so we don't have to worry about that. Okay, here's criteria number 1. My derivative is greater than 0 on the interval from negative infinity to 0, from 4 to 6, and from 6 to infinity. Okay, my second criteria. My derivative is less than 0 on the interval from 0 to 4. Third criteria, my derivative at 0 is undefined. Ooh, that's cool. And last criteria, my derivative at 4 equals my derivative at 6, which equals 0. All right, so let's talk about what these different things mean. If my derivative is greater than 0, that means positive. That's all that means. So if I have a positive derivative, what did we say? The slope of the tangent line is positive, so what's my graph doing? It's increasing. Good. Now, if the slope of my tangent is negative, which is less than 0, then that's decreasing. Yeah, see, you're getting this. If my derivative is undefined, what is happening at undefined? Yeah, remember what we talked about with our critical values? Yeah, and anytime I have a derivative at all. Now here's the kicker. It could be an asymptote, but what do we know up here? Yeah, my graph is continuous, so it can't be an asymptote. So that means I need a vertical tangent. What happens when I have a vertical tangent? Yep, I have a cusp or a point. Remember, that's when my derivative is undefined. Okay, what happens when I have a derivative that equals 0? Yeah, maximum or minimum. Those are those critical values. Well, okay then. Let's do this thing. I'm going to make this just a little bit more here. Let's see what we've got. So I'm going from negative infinity to 0. So I know that this is positive. Let's split this up a little bit here. 1, 2, 3, 4, 5. And it looks like I've got 6 as an option. Oops, I meant to grab this circle. 6, 4, 0. Okay, so these are things that we're looking at. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. We know where 0 is. Okay, we're just hitting the highlights here of what we've got. Alrighty. So I know that my graph is positive from negative infinity to 0. So from negative infinity to 0, I'm at positive. So that means my graph is above that axis, right? Okay, good. And I'm increasing. That's what I'm talking about, increasing. Also from 4 to 6, I'm increasing. And then from 6 to infinity, I am increasing. All right. Well, I'm negative, so I'm decreasing. Let me change my color up a little bit here. From 0 to 4, then I know my graph is decreasing. Okay, good to know. So it's negative slope, so my graph is decreasing. All right, so I know when my derivative is at 0, here I've got some kind of a cusp or a point that we're looking at. And so we're just sketching any kind of a graph. So I don't know if this is above the axis, below the axis. I don't really care even. But I know that there's going to be kind of a cusp or a point here. I also know at 4 and at 6, I have a maximum or a minimum. So let's see what's happening. Horizontal tangent no matter what, right? Horizontal tangent. Okay, so let's draw something. I know that my graph is increasing, so I'm going up, and then at 0, I hit some kind of a cusp. So we're going to say cusp. And then I decrease all the way to 4, so I'm decreasing over here to 4. Then from 4 to 6, I increase again, and I know I also have a minimum there at 4. So at 6, I also have a horizontal tangent. But I'm still increasing. Okay, let's check this out. I am increasing to a cusp because it's undefined at 0. So here at 0, I have this cusp. Then I have a horizontal tangent at 4 and 6. So here I'm going from decreasing to increasing. From decreasing to increasing. Then at 6, I have another horizontal tangent, but it's just that horizontal tangent. However, if my graph is increasing and increasing again, then I have to keep increasing on up. I just have that horizontal tangent. All right? So if you go in the same direction, like here, we're going up and up, then you have horizontal tangent, and the graph just flattens up for a little bit. So my graph's just going to flatten at that critical value. I should write that, at the critical value. Critical value. So my critical value here of 6, my graph flattens because it tells me I'm increasing. So increasing, so I flatten out a little bit and keep going. All right, so all of these are important pieces of graphing, and you need to make sure you pay attention to those because that'll make an impact when we start graphing here shortly. All right, good job, guys.